Section 3-1 and 3-2, lines and angles formed by parallel lines and transversals. The objective of this lesson will be to identify parallel, perpendicular, and skew lines, and to identify the angles formed by two lines and a transversal. Okay, let's review some vocabulary for this chapter. We've got parallel lines, which we mark using these two lines. This is a symbol for parallel, and these are lines that are coplanar and do not intersect. And on the figure on the right, you'll see that line AB and line EF are both parallel, and line EG and FH are also parallel lines. Perpendicular lines are used writing this upside down T, and these are lines that intersect at 90-degree angles. In the figure, we have lines AB and AE that are perpendicular, and lines EG and GH are also perpendicular. Skew lines are not coplanar, skew lines are not parallel, and they do not intersect. Okay, so in the figure, an example of skew lines would be line AB and EG. Parallel planes are planes that do not intersect. In the figure, plane ABE is parallel to plane CDG. Okay, let's see if we can identify some of the vocabulary words we just covered. For number one, we want one pair of perpendicular segments. So we could choose line AE perpendicular to line EH. And there are many different examples that you can choose from this example. One pair of skew segments. Remember, skew segments are not coplanar, so I'm going to choose line AE and then line BC. And we don't have a symbol to represent skew, so we just use the word and to identify both of them. Number three, one pair of parallel segments. That would be AB is parallel to DC. And we use these arrows right here to represent that the two lines are parallel. Last one pair of parallel planes. So we're going to use plane ABCD. It's parallel to plane EFGH. And once again, there are other examples you could have used for this one. Another vocabulary word we have is the transversal, and this is a line that intersects two coplanar lines at two distinct points. And in this example, line T is the transversal, and it intersects line A and line B. Now in the next few slides, we're going to see what names we give to some of these angles that are formed by a transversal. The first one is your corresponding angles. These are angles that lie on the same side of the transversal and in corresponding positions relative to the parallel lines. And here we've symbolized this by using symbols. So one pair of corresponding angles are where the two circles are. Another pair of corresponding angles are where the two stars are at. Our second type of angles are the alternate interior angles. These are non-adjacent interior angles that lie on the opposite sides of the transversal. Notice the name, it says alternate interior angles. So they alternate sides and they're inside your parallel lines or your two lines here. So these two right here, the two stars, are your alternate interior angles, and the two circles are another pair of alternate interior angles. Now we have your alternate exterior angles. These lie on opposite sides of the transversal T, outside lines A and B. So remember the last one was interior angles. This one is exterior angles. These angles are located outside of your two lines that are being intersected. So the two circles, those are a pair of alternate exterior angles. And then where the two stars are, those are also a pair of alternate exterior angles. The last type of angle we have is the same side interior angles, and these are interior angles that lie on the same side of the transversal. So they're interior, meaning they're in between the two lines being intersected. So the two circles right here, those would be same side interior angles, and then the two angles where the stars are, those are also same side interior angles. Okay, now in example 3, what is the value of x? Notice once again we have parallel lines, and these angles are called alternate interior angles. And that postulate that we read a couple of slides ago says, if you have parallel lines, then the alternate interior angles are congruent. So these two would be congruent, and because of that, I can set up this equation and say that 55 degrees is equal to x plus 25 degrees. And then I would just have to solve for x. So here I would subtract 25 from both sides. This goes away, so I get that x equals 30. So that means that this is 30 degrees, or sorry, x is equal to 30. So 30 plus 25, this should equal 55 degrees. Our other two theorems here, we have your alternate exterior angles theorem, which says if two parallel lines are cut by a transversal, then two pairs of alternate exterior angles are congruent. And then our same side interior angles theorem says if two parallel lines are cut by a transversal, then the pairs of same side interior angles are supplementary. So let's go ahead and do some examples so you can see what these theorems are telling you. Example 4. What is the value of x? Now notice these two angles, we don't have a name for angles that are on the same side and on the exterior. So we're going to have to move some of these. Now if you remember from the last chapter, we know that 76 degrees here will also be 76 degrees here as well, because these are vertical angles. And this right here is 2x plus 4, and this angle right here, which is vertical to that angle, is also 2x plus 4. So here now we have two angles that are on the same side of the transversal, and they're interior of the parallel lines. So these are same side interior angles, and our theorem said that same side interior angles are supplementary. So if I take these two angles, they will add up to be 180 degrees. Okay, so this is for same side interior angles. Okay, so let's go ahead and solve. 76 plus 4 is 80, plus 2x equals 180. If we subtract 80 degrees, we're left with 2x equals 100. And when we divide by 2, x is equal to 50 degrees. So we've solved our problem using the same side interior angles theorem. Example 5. What is the value of x? Now here we have more information than what we need, but we're going to go ahead and see which angles we know have a theorem to go with them. By looking here, I know that angle here, 95 degrees, and this angle right here, there's not a name for this type of angle, not a theorem that tells me something about them. But this angle right here and this angle right here, the 85 and the 2x minus 5, these are alternate exterior angles. They alternate the side that they're on from the transversal, and they're exterior on the outside of the parallel lines. And our theorem for those angles say that they are congruent if they have parallel lines separating them. So we have that here. And because they're congruent, we can just put 85 is equal to 2x minus 5. To solve this, we would add 5 to both sides. So now I have 90 equals 2x, and we divide both sides by 2, giving us x is equal to 45. Okay, so this angle and this angle are alternate exterior angles, and they are congruent when we have parallel lines. Okay, now let's go ahead and try a proof here. On this one, we're going to prove the alternate interior angles theorem. And we have here given that line A is parallel to line B. So I'm going to go ahead and mark up my figure. This is parallel to this one. I'm trying to prove that angle 3 is congruent to angle 6. Okay, so our very first line here, this is our given. And then this is what our proof is. So let's go ahead and see. They're wanting us to prove that angle 3 and angle 6 are congruent. We have some postulates that we already learned in this section, and we're going to be using those. And let's see what they have us starting here with. Angle 2 is congruent to angle 6. Let's take a look at these two angles. Do you remember what these two angles are called? Angle 2 and angle 6 are corresponding angles. So the reason they're congruent is because of the corresponding angles postulate. Okay, number 3. Angle 2 is congruent to angle 3. Angle 2, angle 3. Why are these two congruent? Do you remember what they're called? Angle 2 and angle 3 are called vertical angles. This is why they are congruent. And now in our last step, angle 3 is congruent to angle 6. Notice we already have them marked up, so they are congruent. Why are these congruent? If we look at the two previous steps here, notice what is repeated in these two steps. Angle 2 is repeated. Do you remember the property that we use where we cut out something that's repeated? If you don't, be sure to look over your properties notes. When you have something that's repeated that's congruent to something else, in this case angle 2 is congruent to two other angles, if we cut that out, then what's left has to be congruent to each other. This is called the transitive property. Now you could have also decided to use the substitution property. That would have also worked. We could have said that we substituted angle 3 for angle 2, and that would have been a sufficient justification as well. Okay, but in this case we're going to use transitive property to help you remember what those are. If you have any questions, come to class ready and prepared to ask tomorrow.